Now we can derive one relation by using the simple pendulum. So time period of the simple pendulum. So we are going to derive the equation for the simple pendulum by using the dimensional analysis. Length of the pendulum we can take as L, and mass of the pendulum is m. Acceleration due to gravity is g. So we can derive the time period. So that is directly proportional to Lmg. Constant k equal to 2 pi. So t is directly proportional to Lmg. We have to put the power a, b, c. We don't know that power value. That's why we are writing a, b, c. We can write a, b, c. So a, b, c are the constant. Okay. So t is directly proportional to length of the pendulum, mass of the bar, and acceleration due to gravity. So proposed mark is that. So to convert that proposed mark into equal to mark, we have to multiply the constant. That constant value is k. So t is equal to k into L power a, M power b, and g power c. So we are relating these three physical quantities with time period. Okay, by in the dimension formula, we can relate only three physical quantities. So a, b, c are the constants. So now we have to calculate these three values a, b, c. For time period, dimension formula is t, length is L, you know that. Then mass equal to m. This is the acceleration due to gravity. Acceleration, you know that. L t power minus 2 is the formula for g. So substituting all these values in that equation. K is a constant, it does not have any dimensional formula. So substituting that value, see that. So you are equating that equation. So L, A, B, C, and substituting that value equal to L power A, M power B, and L power C, you are getting like this. M power B, L power A plus C, T power minus 2C. So now that equation 1, comparing the right side and left side of that equation. Right side M power B is there, left side also is there. So comparing that equation, T power minus 1 on one side, that other side T power minus 1 is there. Okay. So they can take, that is the equation number 2. Suppose they are taking. Now we can see the comparison. So ML is not on that other side, only T value is there. Time period மட்டும் தான் அது, மீதி ரெண்டும் இல்ல. அதனால M power 0, L power 0 போட்டோம். So now we can compare the A, B, C. B equal to 0. C, A plus C also 0. But 2C equal to 1. Because time period T power has 1 value. We are comparing the two sides of the equation. So we can write C is equal to minus 1 by 2. Right? C is equal to minus 1 by 2. A equal to 1 by 2. Substituting that C value in that equation, you will get A equal to 1 by 2. And substituting all these values in that equation, T equal to KL, A value 1 by 2, M0, C power minus 1. So when you are writing like this, finally you will get K into root of L by G. K, you know that is 2 pi is the constant. So T equal to 2 pi root of L by G. So L power 1 by 2, G power 1 by 2. Then K equal to L by G whole to the power of 1 by 2 அப்படின்னு போட்டுக்கிறோம். காமனா போட்டுட்டோம். அதே மாதிரி மேல பாத்தீங்கன்னா K L power 2 M power 0 அப்படிங்கறதுனால அது 1 ஆயிடுச்சு, அதனால அது இல்ல. So இதே மாதிரி பாத்தீங்க அப்படின்னா we can relate the other equation also. S equal to UT plus half AT square also. So this one we know that UT plus half AT square is the formula we already we derived that and we find out that the equation is correct. So this is a calculation. So we are pushing that object, there the force is acting on that object, the direction. The force and the movement of the object are in the same direction. The force equal to ml t power minus 2. The unit of force is Newton, you know that. So CGS unit of force is dyne, that is in CGS system. Right? That 1 Newton equal to, this is the 1 kilogram, 1 meter, 1 second power minus 2. Okay, it's a MKS system. So these are all the different methods, systems to measuring the length and mass and time. So 1 dyne equal to 1 gram, 1 centimeter and 1 second power minus 2. So substituting that value, we can convert that from one form to another form. So ml t power minus 2 is the ordinary SI unit. So you can convert that into 1 Newton equal to 10 to the power of 5 dyne. So dyne is another one method. So this is another some physical quantities for density, G, volume, pressure and force. So these are all the quantities are we measured by using the dimensional formula and dimensional analysis. So this is the use of dimensional analysis and limitations on the dimensional analysis. And some more points are there. So now we are going to see that other one point for the dimensional analysis. So dimensional based functions, trigonometry, logarithmic, exponential. So these quantities cannot be expressed in terms of dimensional analysis. So we are not able to do the calculation in trigonometry, logarithmic, and the exponential values. Okay, there is a limitations of the dimensional analysis. We are not able to do the calculation in trigonometry, logarithmic, and the exponential. So angle has a ratio. This is for the arc, and refractive index has a ratio. This is also another one thing. So we can calculate that length by length. So it has the no dimension. Like that, the refractive index also does not have any dimension because it is divided by the same quantity. So it is also become 0, right? So this type of some variable quantities are there which does not have any dimension. So unit conversion. So how to convert the unit from millimeter to centimeter, centimeter to meter, meter to kilogram. So okay, dimension for length is L, mass equal to M, time period equal to T. But so how to convert that from equation? You can see that. Last one, testing. So how to test? So consistency. So length equal to length nu vandhudu. Appo nama enna soltom? That formula is correct nu soltom. Suppose varla appadina, that is fail. That equation is incorrect. So consistency means we have to prove that the right side of the equation and the left side of the equation is correct, means that is false. So equation need not be correct, but it is dimensionally correct, but it is not need not be a correct equation. But it has a consistent. Okay, that will be false. So for s equal to ut plus half at square, length equal to length. That is an example for the consistency. Next thing is length, time, and luminous intensity. So length, we are measuring the volume, amount of substance, force, that electric current, density, work, luminous intensity. These are all the fundamental quantities. So dimensional formula for pressure. Pressure already we calculated that. This is the method of doing the calculation to find the dimensional formula for the pressure. And you can see that these two quantities, energy and the torque. So you can see that energy and torque has the same SI unit. It has the same dimensional formula m L square T power minus 2 for the energy. At the same time, torque also has the same dimensional formula m L square minus T power minus 2. These two quantities has the same dimensional formula and the same unit. But these two quantities does not have any same properties. So dimension is same, but it does not have any same property or the characteristics. Okay, you should not relate that thing with the character and that physical properties. So lesson over, ma.